Hello again after the short break. I hope you're refreshed and you're ready for the next portion of very interesting knowledge because we are going to learn something new, at least new for me. So, the gentleman I have here with myself is Chris Hoult. Chris is a founder of Xarma Consultancy in UK, and Chris is going to tell us about some interesting streaming processing technology called Benthos. Chris, the stage is yours.
Thank you. Hopefully you can hear me. Um, Good morning, everyone. I think the word is ačiū for Lithuania, but and if not, then I've probably insulted a bunch of people. I'm Chris Hoult, and this is an introduction to Benthos. So a little bit about me. Who's the beard? So you can find me in multiple places at Choult, Choult. I've got about 18, 19 years in commercial development, mostly Perl 5 and then PHP. So generally you'll have found me on the PHP conference scene, although recently I've been branching out from there. I am the founder at Xarma, a tech consultancy, and what we're doing is all sorts of technical consulting around web technology. So scale up, working with startups and scale ups to figure out their pain points and help move them on. So we're covering a bunch of stuff from Elasticsearch to M&A activity at the moment. Formerly, I was a principal software engineer at Datto for business continuity. I was a senior engineer at DataSift, where we were reading all your Twitter comments, Facebook comments, likes, etc. Senior at Timeout Digital, where I was looking after the timeout.com websites. And prior to that, spent a lot of time in intranets and the early fintech sector. And in my spare time, I am an improv comedian and an actor. So if you recognize my face and you've been to Reading and you've seen shows, it might be that and not my tech stuff. So Benthos. I appreciate that for some of you, it might be hard to do the th in Benthos, and it might be a slightly weird word, but what is it? Well, originally, it just means the crud or the sediment at the bottom of the sea or the lake. So really horrible stuff, boring stuff. But what I'm talking about today is more better described as fancy stream processing made operationally mundane. So the general thought is it's a real boring, it makes streaming boring. And that's why it's got this very cute mascot. Thank you very much, Sebastian, who was telling me earlier it was an awful mascot. No. The blobfish, which looks horrible, but it does some very wonderful things. So it was originally developed at DataSift by a colleague of mine, Ashley Jeffs, where we were ingesting a bunch of different social media platforms and streams, bringing the data in. We were processing it, enriching it, and then selling it on in some circumstances, or archiving it and making it available for aggregation purposes. We were doing a lot of custom work for these things, and it was realized that actually we could replace a lot of components with a single component that was driven by configuration. So we replaced a bunch of our platforms there, and it's currently still in use now that DataSift has been purchased by Meltwater. It is a declarative configuration, YAML files, although they're working on Q as well. It's stateless, and the processing steps are chained. It's a fantastic piece of kit. I'm not selling it, though I will very much help you build your stuff. But I'd love to go into a few of the reasons why I think it's a really fantastic piece of software. So, what is it? It's processing streams. We've got ins, we've got processing, we've got outs. So how do we plummet? Well, generally, like I said, we have a few top level concepts: inputs, processors, and outputs. Those inputs can be single event or it can be batched. You've got all that on the in and the out and in the processing. And that allows fan in, fan out, and all sorts in between. It's got caching as a first-class citizen. Metrics, logging, and tracing are also very much there in the foreground, so that you can keep an eye on everything that it's doing and understand what's going on at the time. So we can look at a few of the inputs. There are over 40 bundled. and you can broker from multiple sources. So your pipelines can ingest from multiple sources at the same time and bring them into the same processing pipeline before fanning out. There are many different types. I've grouped them like this, but you can group them separately. So you got your queues with 0MQ, Rabbit, etc., supports with the MQP, and Kafka, which is my personal favorite. Got the file side of things where it will actually go into S3 and load files for you, or pick up stuff from SFTP or CSV files. One thing it doesn't have just yet is a file watcher, but I'm working on actually introducing that myself so I can replace FileBeat. Database stuff, so SQL, standard stuff, Mongo, BigQuery. A project I'm working on at the moment, we're actually shunting data from one online tool straight into BigQuery, and it was a very straightforward piece of configuration just to achieve that end. All the work was on the ingest, so that's very useful. Some social stuff, Discord or some Twitter search side of things, and then a bunch more HTTP server client sockets, that kind of thing. And I'll show you a bit of that later on down the line. Processors, and this is where the really powerful stuff starts to come in. We've got kind of two sides of a processor, the input and the output. So the request and input and the result output. Over 50 of these bundled, and lots of different types of mapping, especially the very powerful bloblang, which I'll cover in a bit of detail later. We only have a certain amount of time and there's a lot of features there. But JSON schema for your validation purposes, awk for pulling stuff apart and so on. Some integration bits, so you can actually do some enrichment, hitting a Lambda or serverless function via HTTP. You can hit some SQL queries, some parsing, so you can pull out Avro, which is great with Debezium and CDC type stuff, but also message back and Parquet. Then there's flow control and composition with whiles and fors and switches and parallel type stuff, which allows you to do some more complex construction of your processors within just a configuration language. And then some utility stuff, including rate limiting, which is fantastic if you need to worry about rate limits at your sync end. Deduplication, if you have a guaranteed at least once system coming in, you might need to try and enforce the once on the way out. So dedupe's great there. And then the ever useless sleep for whatever reason you might like. Finally, to cover outputs, again, mostly it mirrors the inputs. You got multiplexing, so you can target multiple outputs for the fan out. You can have fallbacks that allow you to do retries and DLQs. And a lot of them will apply back pressure to the inputs. So if you can't deliver a message, it will slow down ingest at the input side of things, which is very useful. If you're having problems in your pipeline, you're not going to lose any data. Then at the caching level, which is particularly useful when you come to enrichment, but it allows you to do a bunch of fun stuff. There, it's another first-class citizen. You can have these multiple backends. I'm using Redis quite a bit at the moment, but you can use Memcache, DynamoDB, and so on. And there's multi-level stuff so that, you know, if you fail a read, so you have a cache miss, it'll fall through to the next thing and then reestablish the cache in that first level for you. So that's great if you want to just wrap an enrichment with it. It'll fall through on that cache miss, and the first time get enriched, and then the second time it'll just fill that out. Then for all you observability nerds and people who actually want to know that their stuff's working, full-on support for first-class metrics from Influx, Prometheus, Statsy, and so on. There are standard measurements, but you can actually put in your own metrics at any point throughout the pipeline. And then again, with logging and tracing, there's support for the open tracing, open telemetry side of things, Jaeger, CloudTrace, you name it. A bunch of the stuff will have the original spans as they come in, which allows you to track everything all the way through the pipeline. You can also throw stuff to standard out or standard error if you want to collect stuff via your containers output when you're launching in there. So I mentioned earlier the mapping language bloblang. Now, for me, this is one of the most powerful features of Benthos. Benthos is incredibly reliable in my experience. It's incredibly fast, but bloblang takes it to that next level. So it is a declarative mapping language. It basically, you say for your input, you map to an output object or document, and you're effectively stating this is from there. There's full on methods and functions in there. It's very safe, it's very fast. And then there is a plugin infrastructure. And I could have mentioned this for the inputs and outputs and processors already, but you can not only create plugins for bloblang, so you can add your own functions and methods. For example, one of the core contributors has created a sentiment analysis method that you can just call on a text field and it will give you that output. You can actually create plugins for the inputs, outputs, and so on. So just as a pet project the other day, I created an SMTP server input, for example, so that I could actually use it to filter incoming emails and so on for a future project. This bloblang is generally usable throughout Benthos. So you got the main mapping processor in the processor step, but a lot of the inputs, processors, outputs allow you to apply bloblang at that point. So you're not only limited to doing the processing there, but you can actually pre or post process before you get to that processing stage within your inputs and outputs. And a lot of cases, there's some interpolation functionality that allows you to dynamically set some fields in your inputs and outputs, such that, say, you could dynamically set which topic you're outputting to in Kafka, depending on the input message, rather than having to do something more akin to change which output you're hitting depending on the input message with like a switch or something like that. So a brief example, I know that the writing's a little bit small here, but it covers a bunch of stuff. So first off, our input object is this, and root is the output object. You can create local variables, but here you can see a bunch of the assignment. So we're constructing in this message, we're constructing a brand new message, output message called root. We're setting its timestamp to just copy from the input object. If we just said root equals this, it would copy everything wholesale. So we could have skipped some of this, but this particular setup lets us pick stuff apart. The incoming message has a context object that's a bit deeper. So we're just shortcutting some of the language here to allow us to address stuff a bit deeper into the incoming object. You can see some Unix timestamp parsing going on for the timestamp element there. We can also kind of timestamp ourselves, so we can eventually see the difference between when a message was sent versus when it was processed by Benthos. You can see us setting the type of this event as it goes through to a scalar there, propagating some bits and bobs there, and there you can see a bunch of the optional side of things. So if an incoming element isn't set, we can default using the OR method, and we can also unset certain elements in roots just by passing it to delete it. So unset side of things. So, there's a wide variety of stuff here. I promise you I'm barely scratching the surface in this presentation. There is conditional assignment, so we can actually only set things going through if conditions match, so if else, that kind of things, and this can get pretty deep. There's pattern matching and maps, so instead of having to do a bunch of ifs, we can just set up the map and then map stuff across. There's tries and catches, catch and or, for missing values, so that we can kind of be a lot more safe with our processing and overall avoid throwing errors when we're dealing with input messages and trying to output stuff as it goes through. So this is taking too long, and perhaps there's an example I can put forward. There's many things you can do with Benthos. So I mentioned about an SMTP server there. When Mastodon really started taking off, I immediately took to Benthos to create an input for Benthos in pure configuration language without having to write any plugin to ingest server sent events, and parse the Mastodon Firehose into objects to go into a Kafka queue or whatever queue I wanted. But here's a quick contrived example that I've taken from a real world thing I did at Datto, where we had to create an audit log for our customers of actions. So our contrived application, this isn't exactly what we were applying it to, but an e-commerce site. We got some product pages, a basket and checkout. We'll just assume that users are logged in. Basically, I'm generating all these events with a random number generator rather than actually modeling any of this. But let's assume that we got our users logged in. But the pages only really have the IDs of the user and aren't actually able to load the details. I know that a lot of web e-commerce sites, you'd have the username to hand, but imagine you've got a component, or maybe even a component deeper into your stack, where you've got the user ID flowing through, but not the usernames or anything like that. And the only reason you'd need it would be for this audit log concept. There's no point adding that to your application because you're just performing extra actions in order to create this log. It's much better to do it through kind of this offline asynchronous processing step. So imagine as we're browsing through the site or we are constructing our checkout, we're generating these actions as it goes through. I've got a few logging events going in. So view product, add it to your basket, remove from the basket, checkout, and internal server error. So raw logs might look a bit like this. So you might see, an English error and a message in natural language, English in this case, a context object which has a bunch of different codes, product UUIDs, the cost, however many remaining stock, and so on, and kind of this event name. You've got all your log levels, which channel's going in, your timestamp, and so on. And you can see where when we're going, we might have product added to basket has some pieces, product view, different bits, and then a more deep structure when the checkout happens. So if you can see in the final message here, in the item UUIDs field, we've got an array of UUIDs for the items in the checkout there. So just as an example of the kind of thing that we might be putting into our log messages. Obviously, you can put whatever you like in there, but this is my example and I'm sticking to it. What I decided for this slide is called BEK. We're going to take an ELK type approach, but instead of the L, we're going to use B for Benthos. So we're going to ingest all those logs and put them into a document store, in this case, Elasticsearch. Yeah, it's ELK, but there. So we're going to have our application, which is a simple log generator at this time, but we can just imagine it's an e-commerce site. We have file beats to actually ingest the files and send them onto a Kafka topic. Now, there's some benefits to taking that approach. While I'm used to being a PHP engineer, so we don't have separate threads or anything like that. I can't pass stuff across. Actually, if we can throw stuff to file and have something else processing our logs so that they initially are on disk and then are put onto the wire, we can have a bit more reliability. We've got a bit more worries in terms of disk space and log rotation and pieces like that. But in general, if we're putting stuff on disk, we're not having to worry about network partitions or any kind of connectivity issues in that respect, if we can leave that to a separate process from our application. Also, if your app crashes and we're logging via separate thread, and while we're logging by a separate thread, we're throwing straight onto Kafka or another message queue. Actually, the benefits of putting to disk means we won't lose anything there in a catastrophic event. So also with that threading side of things, in PHP, establishing a connection to Kafka each request can be expensive at scale. So again, shipping that off to FileBeat is easiest for us. Obviously, that could be FluentBit, whatever you like. I'd love to be Benthos, but there isn't a file watcher in there just yet, as I mentioned. So I would love to replace FileBeat with Benthos and then use Benthos all the way down. So then we'll fire up a Benthos instance to read the Kafka topic and write it to Elasticsearch. So this is our basic pipeline. You can see that we have two sections, input and output. Our input is simply a Kafka connector. And you can see the dollar parenthesis use here, and that's actually using, this is how you bring in environment variables. So we're actually, when we fire up Benthos here, passing in the list of input and hosts and topics for Kafka, along with consumer groups and client IDs. And this allows us to specify all that stuff outside of our configuration, meaning that this input in particular could be reused all over the place as a standardized input, where we're just actually configuring the already configured thing when we fire up, say, our Docker container running Benthos. And then very briefly, we've got the same again with our Elasticsearch output. We just create an Elasticsearch output. We pass in the URLs that we're going to be posting to, which in this case, we're just using the one, and the index that we're going to push it into. And the result is our audit log just flowing into Kibana, which hopefully I haven't broken anything, and it's still flowing. It is good. And you can basically see here how the actual message is just being placed in, because we've not done any processing, we've not split anything out, we're just passing this through wholesale. So you can see this is the output from FileBeat unchanged as we go in. So you can see FileBeat coming in there. And we can see, if we go back to our table, we can see everything kind of flowing in as we're generating bits and bobs. So we're running at quite the kind of a clip here, doing about 1 a second at the moment. So basic stuff, FileBeat straight into Kafka, straight into Elasticsearch. But obviously, we're trying to make some use of that log. We're trying to understand it a bit more, and we're trying to create something that makes it a bit more suitable for human consumption, but without having to alter the application creating the log. I'm very much a fan of trying to do stuff without altering the source. So in maybe a more traditional approach, when you're not thinking of this event streaming side of things, if you're going to create an audit log, you might create very specific audit log emission elements within your app to specifically record, here's an audit log event, here's one here. If we can actually derive that from our logs, that will allow us to generate that audit log in a decoupled fashion from that application. So if we can avoid altering that system, we can reduce the complexity of that system that we're logging from and put all that in our stream processing. So our moving parts for this audit log is we've already just established this FileBeat to Kafka pipeline. We're going to add a Benthos instance to filter and then normalize the application logs into the format that we want, and then place it onto another Kafka topic. And then we've got Benthos at the end, another instance of Benthos to sync from that audit log into Elasticsearch. Now, obviously, we could have just gone straight to Elasticsearch, but I find if we're creating things like an audit log, that ends up being something that would be potentially useful for other applications to consume. So putting it straight into a sync from your processing step isn't always the best thing if you then want to maybe drive more functionality from that fire hose of stuff that's going on. So if you can split it up into multiple streams, where one stream is processed and another stream straight to the sink, that allows us to have multiple sinks or multiple things there. So we might be able to add a WebSocket consumer that will notify our customers when an audit log event happened, or our ops team when an audit log happens, without having to do any expensive Elasticsearch scanning or Elastalert or anything like that. So what we want to do is go from this pretty raw message on the left-hand side that we just saw in Kibana and boil it down to something a bit more consumable, where it's a lot less deep. We're missing or we're removing a bunch of the moving parts that come from a logging pipeline, and we go into more of an audit log or audit event object kind of view. So effectively, we're extracting pieces of the context. So there's a basic processor we're going to do, but you can see how we're going to change a few names of fields and generally shift some stuff around. So this is our two steps. First of all, what I would do when we've got a generalized logging stream, we'd want to filter out or filter for. We want to filter out anything we're not interested in, or filter for anything we are interested in. That allows us to kind of reduce our processing work that we need to do, such that we're only picking out the messages we're interested in. So this first block here is a bloblang block that allows us to first parse that JSON block. You'll note that the original message actually had, well, actually, if I show you in here, this message is actually JSON on the wire. This isn't a complex object. This is just a string in this message field in JSON format. So the first thing we need to do is expand this piece here. So we grab that message field, we parse it as JSON. We then map our root, our output object, to be that full value. We want to discard most of what was in that top level object, but we do want to bring in the timestamp field from that top level object. We then have the ability to map our what we're interested in, and because we used a code that is dot separated, we could use this map to then map product.view or checkout or basket.add or basket.remove to a true or a false field. So that let map results line, penultimate in the gray area, allows us to get that true false. And if we haven't got a value, so it's therefore false, we will then delete that object, which means it just drops out of this processor altogether, which then allows us to skip anything further down. We then have the normalization side, which is basically just picking a few things out and moving them around. So we map the whole thing in. And then what we can do is kind of rename some fields as we go through, delete some fields that we didn't want, and just generally kind of reformat things as we need. And once we get to the end of that, hopefully, again, if I haven't broken things, we should, in our live examples, have this JSON object. So you can see within Kibana and in Elastic, our object is now a lot more readable. It's a lot more concise and more appropriate for an audit log as opposed to just an unstructured or half unstructured log. And you can see how we've just mapped those objects through. So what that doesn't do is it doesn't allow us to see that who this user is or what product this is. Now, obviously, when we're post-processing our logs, we could look this up in a presentation layer, but actually it might be more useful for us to include this in the audit log itself. So to do that, we want to go through and enrich our logs. with that extra information, that would be really useful to do at write time rather than have to worry about mapping things at read. If we can do it at write, it will vastly outweigh any of our processing issues when it comes to the read things. So we have a nice, fast, zippy audit log that we can present to our customers. So we take that output from Kafka that we just created, and we're going to add another Benthos instance, which will input from that log topic. And we'll place it onto, we'll enrich it by hitting a CRUD API with those UUIDs and place onto a separate Kafka topic. So again, it's that same concept of building up separate streams to allow us to tap that process at whatever level we need in order to drive more functionality further down the line. So, and then we've got another Benthos to sync that topic into another index. So effectively, we want to go from our structured piece that we built in the last step and enrich it so that we've got this products object and no longer have to just present the product UUID, and or rather it's a products array, isn't it? And a user object, so that we can expand from that user UUID into some actually useful piece. So we can see that Daniel Boone, that famous technologist, has just viewed a Dell XPS 16. What we can also do with our product view, or actually check out, I can see a mistake there, but if we checked out multiple things, we might want to expand that product list into multiple outputs there, multiple items in the log there. So how do we achieve that? We can create an HTTP processor. Now, I'm not showing you a caching level as part of this, but you can imagine we could wrap this with a cache so that we're not hitting it every time. But this is a good example of how we do what's called a branch processor, which just allows us to kind of step out of the main processing pipeline, where it's this, that, kind of take a step away and map stuff back to the original message whilst processing that full message in the first place. So that request map just says, hey, we're going to deal with the full object that's coming in. We're going to use an HTTP processor, hit our CRUD API, and we're going to hit a specific URL, v1 product, with the product UUID that is pulled from our view. So we saw in that input item, we got a product UUID, JKL012 on the left there, and we just want to hit that CRUD item there and then flesh out the product object with the response, the whole response of that HTTP piece there. Now, one thing I didn't kind of talk about earlier is some of the composability in Benthos allows us to create resources. So instead of having to kind of copy paste all over the place or have very deep pipelines and a full-on configuration side of things, we can actually create resources which are reusable components within the Benthos configuration language, and that allows us to do all sorts of fun stuff down the line. Or we can separate our resources into separate, say, YAML files and include them such that we can swap those around to construct pipelines differently each time. So we named this one the product resource. And now I appreciate it might be a little bit small for you again, but here's an example of how we can actually process that array of item UUIDs and apply it to the processor as we go through. So this is that kind of branch request map I mentioned earlier. We're doing this again, pulling it out. We are then pulling out the item UUIDs into our root object. We are expanding that array of UUIDs into separate messages with this unarchived thing. So you can see we had multiple UUIDs for the products. For example, we expand it into multiple elements. We then pass that through our processor, where for each one of those elements in that array of UUIDs, we are going to run our product resource that we just saw constructed there. And then in that second gray box, we'll bring it all back together again. So we're effectively expanding the item UUIDs, running our CRUD enrichment, and then combining them back again, passing it through and going back so that we have that array of product IDs where that already existed. And so with that, you can see that we are hitting for each of our product views. We can pull out the UUID pieces like that and expand that into the products field. And also, I've added another CRUD, which allows us to take the user's UUID and turn it into a user object. So again, if we can look at the JSON here, you can see how we pulled out the product into an array, manufacturer and its name, and we pulled out the user from its UUID in the original message into this complex user object. Running a little bit out of time here, but just because I could, I also managed to build a CRUD service in Benthos to achieve this. So instead of having to write anything else to do this, I built a small HTTP server input, which returns the results of a SQL query based on the inputs. Probably don't do this, but it's possible. So just showing off. So again, straightforward. There's the HTTP server input where you can just specify the paths, and it pulls with the get. It will pull that class name and UUID into the object coming in. You can see there is a pipeline of processors where it will do MySQL connection with the this is just a select star where the UUID is the one that's come in. Actually, what you can see in args mapping, just a bit further up, if you can pick that out, UUID, which came from the URL, is actually placed into the meta field. Every Benthos object that's flowing through has both the actual data and a meta field, which is really useful for attaching kind of Benthos specific information without polluting your actual item going through. You then pull out whatever the response is and then map it back to our HTTP request with this sync response processor, which basically says we're going to respond to the HTTP server request with the object we just picked out of the SQL. So running out of time here, but there are a bunch of different ideas of stuff you can build with this, really simple stuff to really complex. Obviously, you can build up a whole pipeline of pipelines, as I kind of talked through during this presentation, but you can build out webhook engines. So when an event comes through, just hit HTTP endpoints. You can do change data control processing with that Avro piece. So hook it up to Debezium, and then you can just sync Elasticsearch writes from whenever your database changes and so on. Your alert resolution, again, with CDC type of things or generation, Slack integrations, hit those webhook, it's WebSocket notifications on your site if you're not using something like Node, or you've got a multiple discipline backend, social media monitoring, web scraping, all sorts of stuff can go through there. The world is your oyster. So why should you use it? I've not left very much time to talk about this, but there's a bunch of fun things. So Benthos Studio is a project that Ash Jeffs has been working on that kind of is this more graphical interface that allows you to have a look through your pipelines and map them out in front of you, which is a fantastic little piece of kit for visualizing what's going on. It is built for stream and batch processing from day zero. It was built to do this stuff. It is not an extension of an old project that somehow found its way into this. It was built to do this. It's got unit testing so that you can test that your inputs match expected outputs. You can easily run that within CI/CD. It runs in a very nice serverless mode with that statelessness. It's perfect for running in your Lambdas, OpenWhisks, etc. It's very quick to start up and shut down. If you've used Logstash before, that's a quite slow sometimes. It does give solid delivery guarantees, and it does apply back pressure to inputs where that's available. If you hate YAML, like some of my friends do, it does have experimental queue support, and the community is highly engaged. The amount of traffic in the Discord server is going up day to day. The creator, Ash Jeffs, and the core contributors like Mihor are perfectly responsive. It's one of the best communities that I've been involved with. You can also talk to me there if you really like. So, with that said, if you use Benthos, you are guaranteed to be more popular. Thank you very much. Run out a bit of time here, but if you want to learn a bit more, there's fantastic, one of the best bits of documentation for any platform I've ever seen at benthos.dev. You can find us on Discord as well. So jump from there. If you want to find out more from the presentation, just the examples there, you can go to github.com/chult/benthos-pres. I've been Chris Hoult. You can find me on LinkedIn, and you are free to email me, chris@zarma.co. Thank you very much.
That was a very bold point on getting more popular, Chris. So let me ask one question, because you are advocating for Benthos, you are presenting its good sides and advantages, but are there any scenarios where you would actually not use Benthos, where you would use yet some another streaming technology, because maybe Benthos has still some room for improvement, or maybe this is not just designed for this particular kind of scenario? Is there anything that comes to your mind?
So a lot of people are using Flink, and one thing that Benthos is, I mean, you could probably get it to do it, but it would probably be a lot of work. What Flink allows you to do is do that kind of live querying on your data set. So it'll collect that data as it flows through, and you can do that kind of live querying. That's not what Benthos is for. Like I said, Benthos is stateless. It might allow you to shift stuff into caches, but ultimately it is about processing the stream, not about querying it. And there are a lot better technologies for querying the data, such as throw it into a persistent sink, like your Elasticsearches or Redis or anything like that, or do that kind of more live approach with Flink. So there's a bunch of things that you probably don't want to do. This is think high volume, think throw data around, as opposed to and pre-process it or process it, enrich it, rather than do anything that allows you to have that more interactive approach with the data. One person recently launched their production app log processing. I don't know the full details, but they're doing something like 800,000 log message processing, 800,000 logs processed a second across just 3 instances of Benthos. So it's incredibly fast. It's written in Golang. It's incredibly fast and very performant. I have no idea how deep that processing pipeline is, but it just gives you a vague idea of the kind of volumes it can achieve on fairly limited hardware or VMs or anything like that.
There are some nice numbers you've mentioning. What about the resilience? So let's imagine that one of the nodes goes down. So are there any mechanisms that are built in, or is it more about the infrastructure where Benthos is deployed onto?
It's more about the infrastructure. It is not orchestrating itself. You have to do the orchestration for it. So it's not kind of, being managed, anything like that. It relies on, say in Kafka, you've got your offsets. So it relies on that kind of balance, that kind of activity from its inputs and outputs. So long as it can keep track of where it is, it can obviously, with the partition scheme of Kafka, it can pick across, or it can pick up where it left off where appropriate.
Thank you very much, Chris. It seems I have yet another piece of technology to play with over the weekend. So thank you very much for the session. Thank you for sharing your knowledge. And we'll see each other at the next session very soon. Enjoy your break.
Thank you very much. Bye.